Hello everyone, I am Shardul Mahadik and we have Omkar, Aman and Gitesh also with us. Our mentor for this video is Dr. Yogesh Padia, who is certified energy auditor and professor at Don Bosco Institute of Technology. He has wide experience in not only in energy audits but also implementation of energy cost reduction projects for industries and commercial buildings. So today we are going to discuss on selection of fuels in HVAC industry. Let's first understand what is fuel. Fuel is a substance that releases thermal energy when burnt or undergoes a chemical reaction. The generated energy can be used for various applications such as cooking, running boiler, engines and many other related applications. Types of fuels. Fuels can be classified into three types: solid fuels, liquid fuels, and gaseous fuels. Solid fuels refers to various forms of solid material that can be burned to release energy, providing heat and light through process of combustion. Some examples of solid fuels are coal, wood, biomass, briquette, rice husk, parali, etc. Liquid fuel is a combustible substance in liquid form which is used to obtain thermal energy after combustion. Some examples of liquid fuel are crude oil, diesel, gasoline, FO fuel oil, light diesel oil LDO, heavy fuel oil HFO, etc. Gaseous fuels are obtained either naturally or by treatment of solid and liquid fuels. Some examples of gaseous fuels are natural gas, propane, LPG, biogas, hydrogen, etc. What is calorific value? Calorific value is a measure of the amount of energy released per unit mass or volume of a fuel when it undergoes combustion. Higher the calorific value, more heat is produced by the fuel. Here in the image, wood gives less heat energy and gasoline gives more heat energy, which means calorific value of gasoline is more than calorific value of wood. Here are some approximate calorific values of fuel, and the source of the data is Metrics. The table given below gives some calorific values of fuel. Hydrogen has calorific value of 32,000, LPG has 12,000, CNG ranges from 8,600 to 9,000, petrol and diesel ranges from 10,000 to 10,500, fuel oil FO ranges from 9,800 to 10,300, coal ranges from 3,500 to 8,000, wood ranges from 2,500 to 5,000, briquette ranges from 3,200 to 3,800.
Hello, myself Aman, and in this slide we are going to learn about what are the major factors for the selection of the fuel. The first one is the calorific value. As we know, the calorific value is the measure of amount of energy released per unit mass or the volume of the fuel, which means that the higher the calorific value of the fuel tend to burn efficiently, and the lower the calorific value it burn inefficiently, which causes the problems such as air pollution. The second one is the availability of the fuel. As we know, fuels are the main energy source of any machine. Therefore, the availability is also an important factor, which means they should be accessible and available in abundant amount so that it ensure constant supply of the fuel. The third one is the cost effectiveness. As we know, these fuels are used for industrial application. So, the smaller change in the price, it can cause losses of crore. So, which is why the fuel we consider should be more effective, even pocket friendly. The next one is the environmental impact. As we know, the fuel emit various gases such as carbon dioxide, nitrogen oxide, unburned hydrocarbons, which can cause harms to the environment, human being. So for these reasons, many industries, companies selects the fuel which gives less harm to the nature without impacting the performance. The next one is the sustainability, which means the fuel we select should be sustainable and renewable. This factor of sustainability and renewability increase the life cycle of the fuel. In this slide, we have done the comparisons of various fuel on various parameters such as calorific value, efficiency and heat generated. The first one is the coal and it has a calorific value of 5500 and has an efficiency of 75%. It gives the calorific value of 4125 and if it has a rate of 9 rupees per kg, the heat generated through it is 458 kilocalories per rupees. The second one is the briquette. If it has a calorific value of 3600 and efficiency of 70%, it gives us the calorific value of 2520, and if it has a rate of rupees 7 rupees per kg, then the heat generated through it is 360 kilocalories per rupees. The next one is the FO, which is a furnace oil, and if it has a calorific value of 10,000 and has an efficiency of 80%, which we get the calorific value of 8,000, and if the rate is 60 rupees per liter, then the heat generated through it is 133 kilocalories per rupees. The next one is the CNG, and it has a calorific value of 8600 and has an efficiency of 80%. It gives us the calorific value of 6880, and if the rate is 60 rupees per meter cube, then the heat generated through it is 115 kilocalories per rupees. The next one is the LDO, which is our light diesel oil, and it has a calorific value of 10,000 and has an efficiency of 80%, and we get the calorific value of 8,000, and if it has a rate of 75 rupees per unit, then the heat generated through it is 107 kilocalories per rupees. The next one is the electricity, and it has a calorific value of 860 kilocalories per kilowatt. And if it has an efficiency of 95%, then the calorific value we get is 870. And if the rate is 10 rupees per kilowatt, then the heat generated through it is 82 kilocalories per rupees. Next one is the LPG, and it has a calorific value of 12,000, and if it has an efficiency of 60%, then we get the calorific value of 7,200, and if the rate is 100 rupees per kg, then the heat generated through it is 72 kilocalories per rupees. The previous comparison, we can conclude that a coal appeared to be beneficial because it has a high efficiency, high calorific value, low cost, and required amount of heat is generated. The second one is the coal is a practically and economically viable option for energy generation.
Now, let's consider a real life scenario where in an industry, if we use briquette in place of LPG as a fuel, what changes will be observed in terms of cost effectiveness? Savings due to fuel substitution. The CV and rate of briquette and LPG are assumed. First of all, let's consider daily LPG consumption as 1000 kg per day. So the daily expenses on LPG according to the rate of LPG will be 95,000 rupees per day. Now, if we use briquette in place of LPG, so the equivalent briquette consumption will be 3810 kg per day. The daily expenses on briquette will be 30,476 rupees per day.
and the expenditure on labor for briquette, it would be 3810. So we if we sum up these values, the total expenditure on briquette firing boiler would be 34,286 rupees per day. So, as we can see, the daily savings due to fuel substitution is 60,714 rupees per day. And looking at the bigger picture, the annual saving per year will be 182 lakhs. Now, let's see methods of fuel substitution. First, using internal grade boiler. So, what is an internal grade boiler? An internal grate boiler refers to a type of boiler where the combustion of fuel occurs on a grate located inside the boiler's combustion chamber. This grate is typically made up of metal bars or a plate arranged in a grid pattern. It is used if the boiler is operating at 40 to 50% load. Second, external grate boiler. This is similar to internal grate boiler, but the grate is located outside the boiler. The external grate allows for more space inside the boiler for heat transfer mechanism. It is used if the boiler is operating at 50 to 70% loading capacity. Third, external grate boiler with additional heat transfer area. This type of grate includes additional surfaces designed to maximize heat transfer from combustion process to the water or steam inside the boiler. These surfaces could be in form of tubes, fins, or other configurations that increase the contact area between hot gases and the boiler contents, improving the efficiency. It is required if boiler need to operate at 90 to 100% capacity. Further, we will discuss one more real life scenario.
So here we are delving into a critical aspects of hotel industry, which is water heating. Specifically, we will be comparing four prominent methods for water heating. The first, heat pump; second, LPG; third, electric geyser; and the fourth, briquette-based hot water generator. Each of these options plays a significant role in providing hot water efficiently and reliably to meet the demands of hotel. We will delve into the methodology behind selecting the optimal fuel for water heating applications in hotels. Let's see on what parameters these selections can be done. Suppose daily water requirement is 2000 liter per day and the temperature to be rise is 25 kelvins. So the heat required will be the product of daily water requirement and temperature rise, which is 50,000 kilocalories per day for selecting the optimal fuels. So in the first case, we are using heat pump. Let us assume that the heating COP of heat pump is 3 and the energy consumed by the compressor is 19.4 kilowatt hour per day and the rate of electricity is 9 rupees per kilowatt hour. So we can find out the daily expenditure on electricity by multiplying the energy consumed by the compressor with rate of electricity, that is 174.4 rupees. Second case, we are using LPG. LPG consumption at 70% efficiency is 5.95 kg per day. So we can find out the expenditure on LPG just by multiplying the rate of LPG with LPG consumption, which is 565.5 rupees per day. So in the third case, we are using electric geyser. Equivalent electricity consumption at 95% efficiency is 61.2 kilowatt hour per day. So the total expenses on electricity can be calculated by multiplying the rate of electricity with equivalent electricity consumption, that is 612 rupees per day. And in the fourth case, we are using briquette-based hot water generator. Consumption of briquette at 70% efficiency is 19.84 kg per day and the expenditure on briquette is 198.4 rupees. By considering all the parameters, one can easily say that the heat pump offers a sustainable and cost-effective solution for water heating applications in hotels. If the calculation isn't clear, don't worry. I will make sure to include all the calculations in the description so you can review them at your own place. For further details, contact at padia@dbit.in.